Well, hello class and welcome to the quotient rule. Today we are going to be looking at a rule that is very similar to what you did last time, which is the product rule. You can probably guess that since it says quotient, we're going to be looking at division rather than multiplication. But before we start that, I want to go back to our elementary rule. And you can see in my first example of y equals an expression, I'm going to change that so that we can use our basic power rule to being x over 2x minus 3 over 2x. And then I'm going to change that to being 2 times, pardon me, not 2 times, just 1/2 basically, because the x's cancel out. And then minus 3 half, and then x to the minus 1. So when I apply our basic rule for the derivative and I find the slope of the tangent line at any point, it's going to be positive 3 halves and then x to the minus 2. So we already know the answer before we start. What does the quotient rule say? Well, the quotient rule says that whenever we have a division statement, the slope of the tangent line at any point is the derivative of the numerator, which will be 1, times the derivative, times the denominator, then subtract the derivative of the denominator, which in this case would be 2, times the numerator, all divided by the denominator squared. Let's simplify that. We're in the numerator going to get 2x minus 2x plus 6. In the denominator, we are going to get 4x squared. What do we end up with? 6 over 4, because the 2x and 2x cancel out, which is 3 over 2, and then x squared on the bottom. Same thing as that. So the quotient rule is true. And we're just going to apply it to a number of different scenarios. So to help us a little bit here, I'm going to color code like I normally would do. And we'll talk about the green, which will be the numerator, and the blue, which will be the denominator. And we're going to find the slope of the tangent line to any point on this rational function. So we take the derivative of green times blue, and then subtract the derivative of blue times green, and then all divided by blue squared. So I'm just going to fill all that in now. So the derivative of green times blue minus the derivative of blue times green divided by blue squared. And when we can simplify, we should simplify. So in the numerator, it's reasonable for us to simplify quite easily. And we can times everything out, and we'll get 2x minus 2 minus 2x minus 3 divided by, don't times the bottom out. I can't think of any example where that's going to be useful for us. If there's going to be a mistake made here, it's probably with this minus sign affecting this sign as well. And we've seen that enough where that shouldn't be a big surprise to any of you. So then we would simplify that further, which should be minus 5 over x minus 1 squared. So without having you guys to watch over my shoulder, I may have made little mistakes here or there. Please accept my apologies if I have. But the basic picture you should be okay with. So I'm going to actually jump to the next page here. I think you could probably handle this one. Just remember when you have a constant term that the derivative of 1 is 0. So that's going to cancel out the first term in the quotient rule because the derivative of the numerator will be 0. 0 times anything is 0. So just watch out for that. Let's take a look at this number 4. And again here, I'm just going to color code for us so that it's consistent here. So derivative of the top times the bottom minus the derivative of the bottom times the top divided by the bottom all squared. So the derivative f prime x should leave space for that equals 2 times 3x minus 2 minus 3 times 2x minus 3 divided by 3x minus 2 squared. Anybody want to guess why I'm doing this one? I'm wondering if something's going to be different than the previous question. I'm curious as I continue what that's going to be. 6x minus 4 minus 6x plus 9 over 3x minus 2 squared. Doesn't look like it. I'm wondering why I put this example in. That's 0, and you end up with on the top 5 over the bottom squared. Let's go on to question 5 here, which has a root in it. You can see I have a reminder for myself to take out the common factor let's go ahead and do this question. So remembering that x, or the square root of x part of me, is the power of a half. My derivative in the numerator will be 1/2 x to the minus a half. Well, that's different. Times the bottom. Subtract the derivative of the bottom times the top, all divided by the bottom squared. So now when I look only at my numerator, and I have two issues. One is a fraction. So in chapter 1 we did a bunch of stuff with fractions, and we knew to take out a fraction we need to have a common denominator. So I'm going to change 2 to being 4/2. And then we're going to look at our variables, and I have x to the negative a half and I have x to the half. We always take out the lowest power, which would be x to the minus a half. So in the numerator, what I see we have in common is a half and an x to the minus a half, and we're going to see what remains. Well, we'll have this is out as a common factor, so you're left with 2x plus 1. If you take 1/2 out of minus 4/2, you're left with minus 4. And if you take out x to the minus a half from x to the half, you get a power of 1. And that's still all divided by 2x plus 1 squared. Now we would simplify inside that bracket and almost be done. I am going to cheat a little bit here because I don't have much room. I recognize I'm in the bracket. I'm going to have minus 2x plus 1. I should never have a leading term that's negative. So I'm going to take that negative, I'm going to put it in front of everything. And even I'm going to write things a little bit different here. See if you can catch on after thinking about it for a second, what I'm doing and how those two things equal one another. In particular, where did this go? And you can see the 2 is gone here. X to the minus a half I put to the bottom. I'm not sure in your textbook if they go that far, but I like to keep my exponent positive as much as is possible. So you'll also end up at the end of your assignment with some questions just like you did in the product rule. So you find the derivative, then you're going to have to plug in your x value into that derivative, find the slope. Once you know the slope, y equals mx plus b, or you can use your slope point formula and find the y-intercept or the equation. So you know how to do that. As long as you can do the derivative, you'll be fine. So here's your assignment to work on. Please highlight any questions that you have trouble with. Please ask questions of each other and of your teacher to help each other out. And I will see you next class, and I hope today went well. That's it. That is the quotient rule.